All right, number 1, part A. So on number 1, part A, the way I would approach this one is to I'm going to let U equal the square root of X. So if I take U and square it, that would give me X. So when I write this in terms of U, that would become now X squared. Sorry, not X squared, U squared. U squared minus 3U. I'm going to go ahead and add 2 to both sides equals 0. And then I'm going to factor this. It's over the front page. So this is going to factor to be U minus 2, U minus 1. Equals 0. So U is 2 or U is 1. Now we're going to resubstitute back in. So I have the square root of X is equal to 2. The square root of X is equal to 1. Square both sides. I get that X is 4. And I get that X is 1. Yes, ma'am. Yes, I was hoping to get it up over the weekend, but then I found a mistake in the answer key that I had with me that I was working out and correcting, and so I had to wait until this morning to finish it up. Should be going up by about 3rd period today. Should have all of my work. Yep. Yes, ma'am. 1F? Absolutely. And Eni, I'm not sure if you were in the room when I made this announcement, but number 32 on that answer key that I passed out to you, number 32 was totally and completely wrong. It will have the right work on here, but number 32 on the answer key is totally wrong. All right, part F. So since I have 2 different exponential bases and there's no way that I can take and write the base of 5 in terms of 6, and I can't write a base of 6 in terms of 5. So I can't take my rewriting basis trick here. But what I can do is I can take a log of both sides. We can do common log or natural log, since those are buttons that we have on our calculator. Do you guys have a preference for whether we do common log or natural log? Why don't we go with natural log? It's less letters to write. So I'm going to do a natural log of 5 to the 2x plus 1 equals the natural log of 6 to the x minus 2. Now that I have logs, I can use my powers property and I can drop my powers down in front. I couldn't do that with the original problem because it was exponential, but now that it's a log problem, I can use that trick. So 2x plus 1, natural log of 5, equals x minus 2 times the natural log of 6. I'm going to distribute a natural log of 5 to both of these pieces. I'm going to distribute a natural log of 6 to both of these pieces. So I'm going to have 2x ln 5 plus ln 5 equals x ln 6 minus 2 ln 6. Remembering that the goal of my whole problem is to isolate x. Right now, x is on both sides. It started off in my exponents. Once I took a log of both sides, I could drop the x's down in front and then I could distribute. Now I still have them on both sides. I want to get them over to one side together, and I want to get anything that does not have x's to the other side of the equation. So I'm going to subtract the natural log of 5 from both sides. And I'm going to subtract again, x natural log of 6 from both sides. So this will cancel, and this will cancel. So I'm going to have 2x natural log of 5 minus x natural log of 6 equals -2 natural log of 6 minus the natural log of 5. And then something that I notice over on the left that has happened is there is an x in both of these pieces. There are only 2 terms over on the left-hand side, so I can factor that x out. I don't know if I can do that. Let me give myself a little bit more room there. There we go. I'm going to factor the x out of both of those terms. And then I'm going to be able to divide. So x times 2 natural log of 5 minus natural log of 6 equals -2 natural log of 6 minus natural log of 5. And then I can divide both sides by what's inside those parentheses. And when I do that, so this would be my exact answer right here. And my approximate answer when I pop that into the calculator is about -3.639. What else would you guys like to see me work through? What other questions did we have? Yes, sir. Number 2? Absolutely. All right, a relation which is symmetric with respect to the x-axis. So if it's asking for a relation, I do not need a function. I can have something that when graphed would break the rules for a function. So I'm thinking about this. Here's my xy axis. If I were to draw a shape that looks like an absolute value, but on its side, would that be symmetric with respect to the x-axis? If I fold it over the x-axis, would it have symmetry? Yes. Okay, so it looks like an absolute value function, but it's turned on its side. Absolute value is y equals absolute value of x. So I could write this as x equals the absolute value of y. A function that is symmetric with respect to the y-axis only. So y-axis symmetry. The one that popped into my head here was y equals x squared. Just thinking about a very basic parabola here. If I fold it in half over the y-axis, it would match up with itself. And then they ask us about origin symmetry. Origin symmetry is a rotational type of symmetry. Means like if I had a piece of tracing paper and a push pin, I had my original function on there, I put the push pin down and I traced through the original function. If I spun it halfway around, so 180 degrees, it would match up with itself. The first one that came to my mind here was y equals x cubed. Y equals x cubed, parent cubic function looks like this. Notice on part D, they didn't say a function, they said a relation. So I did not need to write a function rule for this one. I want something that has x-axis symmetry, y-axis symmetry, and rotational symmetry, origin symmetry. So I chose a circle. because that was the one. It has to be a circle that's centered at the origin, or else it's not going to have origin symmetry. But I went with x squared plus y squared equals 4. For parts E and F, for an even function and an odd function, remember, definition for an even function is that f of x is equal to f of negative x. That is our definition for an even function. That if I take a negative x and I substitute it in the place of x, absolutely nothing changes. So what would have to be true about any powers of x? Yes, ma'am. They would all have to be even. So I can write any kind of function rule that I want to, but all the powers of x have to be even. I can also include constants, because if I take a negative x and put it in the place of x, will it change my constant? If I had like a +5 on the end? No, if I put negative x in there, that's not going to change it. I'll write one out and let you guys see, okay? So if I did something like f of x equals 5x to the 6th plus 4x to the 4th minus 7. If I take negative x and put it in the place of both of these x's, that'll stay a 5x to the 6th. That'll stay a 4x to the 4th. And a negative x is not going to affect this at all because I'm not substituting in there since it's a constant. So that also remains unchanged. Every single term stays exactly the same. Our definition for an odd function was that f of negative x is exactly the same thing as taking a -1 times my original function. So based on what we saw on an even function, what would have to be true in order for it to be an odd function? What would have to be true about my powers of x? They all have to be odd. And I can have no constants in this case. Constants can go with my even functions. Constants cannot go with my odd functions. So I could have something like f of x equals x to the 3rd plus x. Could do something like that. If I add a +5 on the end of it, though, no longer an odd function. Even functions, by definition, have y-axis symmetry. So technically, I could have written down my y-axis symmetry equation for my even function. Odd functions, by definition, have origin symmetry. And if you look, this one does have an odd power to it, and all my powers of x there are odd powers. I just chose to write down something that only had one term to it. So anything that I could write for y-axis symmetry, I could write for an even function. Anything that I can write for origin symmetry, I can write for an odd function, and vice versa. What else would you guys like to look at or talk about? Yes, ma'am. 1E? Yep. So the first thing that I notice about 1E is that the left-hand side looks really gross. But I notice that every single one of these terms has at least a p to the 35 to it. So I'm going to factor that out of every term here. So p to the 35 times 6x minus 7 minus p squared, all over p to the 35. So now that's going to cancel with my denominator. Since my denominator's out of the way, I can start doing things to both sides of my equation. I'm going to add p squared to both sides. And that actually ends up canceling out my p squareds altogether. So now I have a linear function, 6x minus 7 equals 2x plus 5. And then from here, I would subtract 2x from both sides. So I'm going to get 4x and add 7 to both sides. So equals 12. So x equals 3. Yes, ma'am. You're going to subtract your powers, yes. So here, that one would cancel. This over here, since it's subtracted by, or it's separated, sorry, by a plus sign, I'm going to subtract those. So I would have a b to the first power there, yes. Which is basically the same thing that we did here. I just chose to factor it out to the front instead of dividing each term, but it has the exact same effect as factoring it out. Yep, good questions. Yes, sir. If the p's couldn't cancel, there are ways to do it, but it would take a very, very, very long time. So, oh, that reminds me of something that I wanted to make sure that I announced to you guys. Speaking of a very, 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 very long time. Your final exam is 20 questions long. It does not have parts A, B, C, D, E, F, G to each question. It is 20 questions. At IU, they sit for 120 minutes, 2 solid hours for this exam. So you guys get 120 minutes. Your in-class time, what Pike provides, is 90 minutes. If you are not finished at the end of that 90 minutes, your exam in here is the last day of finals. I am fine if you come in during 5th period for another half an hour to finish your exam during that time, okay? So please do not think just because I'm telling you that the bell's getting ready to ring that you're done. You still get another half an hour when the bell rings, should you need it, okay? Did want to make sure to announce that. Just let me know before you leave the room the day of our final if you need me to write a pass for you to come back and finish that up. Right. Yes, ma'am. There is nothing on the IU exam that is not covered on this final exam review. And the way the questions are structured here, how there's not like multiple parts to each question, that's similar to the way the questions are going to be phrased. So I might give you a function rule and a graph and ask you to graph it. All right, I might ask you to solve. In this case, I was asking you to solve each of these, but just one of those would be a question. You're not going to have a question with as many parts as number 1 on here. Is it possible that I would give you a question with a couple of parts, or sorry, that IU would give you a question with a couple of parts like number 2, where you don't actually have to do any work? You're just asked to write some things down. That is a possibility. But if it has multiple parts to it, it's not. Each part requires the same amount of work. Does that make sense? Okay. What else would you guys like to look at? Yes, ma'am. 3B, absolutely. All right. So first thing I notice on 3B is that that quadratic looks like it's going to factor. How will that quadratic factor? X plus 2, x plus 2. So x plus 2 squared. So log base 2, x plus 2 squared, all over 2. What kind of expression am I looking at here? First 3 letters are log. What can I do with exponents if I have a logarithmic expression or a logarithmic equation? Put them in front. So I can take this squared, drop it down in front. So I have 2 log base 2 of x plus 2, lots of 2's going on here, all over 2. Remember, once I drop it in front, it's being multiplied to my log now. What can I do? Yes, ma'am. Yes, I can. And so fully simplified would be log base 2 of x plus 2. Yes, ma'am. 3a? Absolutely. Absolutely. I have two of the same base. What do I do with their exponents when they're being multiplied like this? You can add them. So I'm going to take the 8x and the 8 and add those together. So I have common log of 10 to the 8x plus 8 over x plus 1. Using my powers property, I know that this is going to drop down to the front, but then log base 10 simplifies to what? Not just log. This right here, what is the base on that guy? 10, so it's 10 to what power gives me 10? 1. This right here simplifies to just 1. So I have 8x plus 8 times 1. All over x plus 1. What do you notice about the numerator? I have a GCF of 8 here. So I have 8 times x plus 1 over x plus 1. I can cancel my x plus 1's, and this whole thing simplifies to 8. What else? Yes, ma'am. Number 6? Yes. Remember, number 6 was the one that had the typo on it. Should be 60 inches, and on your printed version, it said 30. So that was incorrect on your printed. All right, Malachi's framing a family picture to give his mother for Christmas. He has 60 inches of wood to make the frame out of. So the perimeter is equal to 60 inches. So I have no idea what this picture looks like, but if it is a rectangular frame, one side would be X and the other side, I don't know what it is, so I'm going to call it Y. And if I add all the way around, I get 60 inches. So 2X plus 2Y equals 60 inches. So far, so good? What else do we know about the frame? Has to be at least 216 square inches. Yes. It's a large picture with an area of 216 inches squared. So he wants to make sure that this picture fits in it. If it's a little bit bigger, then he can put a mat around it. So it has to be at least 216 square inches here. I'm going to write this perimeter equation. I'm going to solve this for y. So 2y equals 60 minus 2x. If I take out my GCF of 2, I divide everybody by 2. I get y equals 30 minus x. So instead of writing this side as y, I'm going to write it as 30 minus x. And we know that the inside here needs to be 216 inches squared. So far, so good? Does it have to be exactly 216? No, they said at least. So I'm going to multiply these two sides together. X times 30 minus X has to be at least. So I want this side to be 216 or more. I'm going to distribute the X. So 30X minus X squared is greater than or equal to 216. What type of an inequality am I looking at here? What degree is this inequality? Second degree. So I've got a quadratic inequality here. If it had an equal sign, we'd get it set equal to 0 and factor it. I'm going to do the exact same thing here. I'm going to make one side a 0, and then I'm going to factor it. I don't ever like my squared term to be negative if I'm going to factor, because I'll end up with backwards signs. So I'm going to add X squared to both sides. And I'm going to subtract 30X from both sides. So I have 0 is greater than or equal to X squared minus 30X plus 216. Play around with that for a minute and tell me what you can come up with that multiplies to 216 but adds to negative 30. Negative 36 and 6 would multiply to negative 216. Super close though. It adds to the right amount, doesn't quite multiply to it. Multiplies to a positive 216, but adds to a negative 30. Yes, sir. 12 and 18. So it's got to be a negative 12 and a negative 18 if I'm going to get this to add up to negative 30. Right? Do you guys remember what we had to do when we did quadratic inequalities? This is where I'm going to need a sign chart. I have to use a sign chart to make sure that 0 is greater than these two things multiplied together. So let's come over here and make our sign chart. Don't need it too big. So I've got 12 here. I have 18 here. Remember, this is a number line. And my result is going to be on the bottom. So I'm going to grab my factors. X minus 12, X minus 18. And now we're going to look at what happens. If I pick a number smaller than 12, give me an easy number that's smaller than 12. 11, 6. First thing I thought of was 0. Smaller than 12, right? It doesn't matter what number you pick. I just want to pick an easy number. You could have gone with 10 even. If I pick a number that's smaller than 12 and I pop it into this factor right here, will I get a positive number back or a negative number back? Negative. What about if I take a number smaller than 12 and I pop it into this factor here? Negative. Remember, these are my factors. We're multiplying these factors together. If I multiply a negative and a negative together, what kind of result do I get? I get a positive result. Do I want a positive result from multiplying these two together? According to this inequality right here. I want 0 to be the bigger thing. So when I multiply these two together, I actually want to get a negative result back. So I'm not looking for this interval. We use a sign chart to figure out our intervals. All right, give me a number in between 12 and 18. 13, 16, 15, anything in between 12 and 18. If I go with 13, 13 minus 12 is positive or negative? Positive. 13 minus 18 would be negative. If I multiply a positive and a negative number together, I get a negative result. And give me a number bigger than 18, something easy to work with. What'd you say? 19, 20, anything bigger than 18, right? 19 minus 12 would be positive. 19 minus 18 would be positive. If I multiply two positive things together, I get a positive result. So I've defined 3 different intervals separated by my zeros, right? Since we have this or equal to, I know that we're going to need brackets, but I don't know whether it's a bracket and it goes to negative infinity, bracket, and then it goes to positive infinity, or am I looking at this space in between? What do you think? I want 0 to be greater than. Yes, ma'am. It's possible that I could have an answer like that. What kinds of numbers am I looking for? I'm looking for negatives. Why? Based on the way my inequality is written right here, why am I looking for the negative? Yeah, it says 0 is bigger than. So if 0 is the bigger thing, all the output that I'm looking for has to be negative, or else 0 is not the bigger thing. So I'm looking for this interval right here. I know that feels weird to say I'm looking for a negative interval, but it has to do with the fact that we added that x squared to both sides. So we kind of turned our quadratic around. So normally I would think, well, I need to look for positive values, but that's not going to give me the piece of this parabola that's going to answer my question. So square bracket from 12 to 18, because if I multiply 12 and 18 together, you guys already know I'm going to get what? I'm going to get 216, right? If it has to add up to 60 inches all the way around, if I add an inch to one side, I would have to take it away from the other side, right? Grab your calculators real quick. What happens if I multiply 13 and 17 together? 221, bigger width, or sorry, bigger area, not width. I made it wider on one side and shorter on the other. I got a bigger area. It's still going to fit my picture. What about if I did 14 and 15? Or sorry, 14 and 16? 224. I still get that area of at least 216. If I take other values, like if we said that this was from negative infinity up to 12, then I'd be saying that, like, well, one side of this could be 10, right? So 10 and 10, that'd be 20. So 10 and 20, 10 and 20. Would that add up to 60 all the way around? If I did 10 plus 20 plus 10 plus 20? So I'd have the correct perimeter, but what happens if I multiply 10 and 20 together? 200, not big enough area. So we've got a way of going back in and double checking values inside here, inside that interval. If I use them for x, I should get an area that is 216 or bigger. If I pick values that are outside of that interval, either smaller or larger, and it still adds up to my perimeter of 60 inches, I'm going to end up with an area on the inside that's too small. Does that make sense? Okay. Probably have time for one more if it's a short problem. Yes, ma'am. 5A. Yep, let's go look at it. Oh, that was too far. Backwards. Yep, finding the inverse. This is a nice fast one. So first I'm going to rewrite this just using y instead of function notation. How do we find an inverse? What's my first step on finding an inverse? Switch the x and the y. So this is going to become x equals 2y minus 9. And then from here, once I switch x and y, I want to isolate y. I want to get the y all alone. So I'm going to add 9 to both sides. So x plus 9 equals 2y. I'm going to divide everybody by 2. And then I'm going to distribute with my division the same way I would distribute with multiplication. So I have 1/2 x plus 9/2. Although if you left it as x plus 9 over 2, that would be fine unless the directions said otherwise. So we do need to write this with our inverse function notation. So f inverse of x is equal to 1/2 x plus 9/2. What kind of function is that? It's a linear function. What is our domain for a linear function? Negative infinity to positive infinity, all real numbers. All right. Bell's going to ring for us here in just a couple of minutes, so I kind of want to put things on pause here for today. I'll still continue to take questions, and like I said, all of my work will be going up right around 3rd, maybe as late as 4th period, but it will be up before the end of the day. I just have to find time to actually take pictures of it all and then upload it, okay? But it will be going up today.